All right, I want to say something about graphing of trig functions. I talked about this in class, but I think maybe I need to present a more systematic approach. So I'm going to present approach for 5 steps. 1, identify the parent function. 2, identify the 0 point, and I'll explain what the 0 point is. 3, identify the period. 4, identify the amplitude. And 5, complete the sketch. So I'm going to illustrate these points on this particular problem with a lot of different constants and so on. Now you can memorize what the different numbers mean, but I always like to do my problems understanding the meaning of what's going on. Okay, so first of all, identify the parent function. Now you have a secant in here, but you also have a minus sign. Now you can accommodate the minus sign when you do the amplitude, but I think it's easier just to treat the parent function as minus secant of x. All right, and then you can apply the amplitude and other things directly. So I'm going to take my parent function as minus secant of x. Now what does minus secant of x look like? Well, remember, secant is 1 over cosine. So I draw the cosine first. Now if I take 1 over the cosine, what that means is that whenever I get 0 on my original graph, I'm going to get an asymptote on my on my inverse graph, on my secant graph. Right, now notice if I'm here just a little bit to the right of this 0 point, then cosine is positive. That means the function is going to be, if I take 1 over a small positive number, I get a large positive number. So to the right of this asymptote, the function is positive. To the left, it's negative. This asymptote, it's running positive to infinity. This asymptote, it's running negative to infinity. Now, of course, when I have a point 1, you know the cosine is maximum at 1. When I take 1 over 1, it's 1. Okay, so the secant curve kisses the cosine curve at these maximum points because both have a value of 1. Okay, so given the asymptotes and the vertices, I can graph the function secant. And you should remember this shape. It's a very characteristic shape for secant and cosecant. Cosecant is the same, but you just shift over by pi over 2. All right. Now, that's secant. What about minus secant? Well, minus secant, you just flip around the x-axis. Okay, so I took this bowl here, this light blue bowl, and I flipped it around the x-axis, and I got this purple bowl down here. So my parent function is this purple line here. Okay, and that's what I want to keep in mind. Now, when I say 0 point, what I mean is the point that corresponds to the origin of the parent function. All right, so I mean the parent function is kind of centered around 0, 0, and I want to identify the 0 point, which is the corresponding point in the graph that I'm trying to get. Now, to get the center, the x value of the 0 point, what I want to do is I want to make the argument of the trig function equal to 0. Because that corresponds to when the secant is 0, that's going to tell me where my new secant, where my translated and stretched and distorted secant has its x0 value. So in order to get the x0 point, I take whatever's inside the trig function and set that equal to 0. I take the argument of the trig function and set that equal to 0. And so that's what I did here. 1/2 x plus pi over 3 equals 0. Do my algebra, I get x equals minus 2 pi over 3. Okay, so that's the x value of my 0 point. Now what about the y value? Well, let's pretend the trig function wasn't there. If the trig function wasn't there, then I just have y equals minus 3/5. Okay, so that's telling me that without the trig function I have y equals minus 3/5. That's the y value where the trig function is going to be centered on. Okay, so I have my 0 point, which is minus 2 pi over 3 minus 3/5. All right, so that's going to be important. When I graph my function, that's the first point I'm going to graph. Now notice that this point is not actually on the graph, but this point allows me to orient myself so that I can draw the graph. Right? The 0 point of this secant function is not actually on the graph, but it's kind of the center of the graph. All right, so my next step was find the period. Find the period. What is period? Period has something to do with 2 pi. Okay, so what I can do is I can go and do similar to what I did with the 0 point. With the 0 point, I set what was inside the trig function. The argument of the trig function, I set that equal to 0. Now, if I want to find the period, I put what's inside the trig function and set that equal to 2 pi. All right, so I'll do that here. So I set x over 2 plus pi over 3, which is what's inside the trig function. I set that equal to 2 pi and I solve. Okay, so that's where my first period begins. But I have to remember that the first period, I'm sorry, that's where my first period ends. This is where my first period ends. But my first period begins at the 0 point. The first period is going to run from the 0 point to this point. So if I want the period, I have to take the difference of these two. So this is where the first period ends. So let me just write that in, just to be clear. Right, this is where the first period ends. Oop. Is it working? Okay, here we go. Okay, this is 2 pi. Now I've gone a full 2 pi, and that's where I end up. But then if I want to find the period, I have to take the difference between this and the starting point of the first period. So I end up with 4 pi. Now you can memorize also that the period is 1 over the coefficient, but this shows you why that's true. So I don't like to memorize. I just like to go according to comprehension. All right. Now the amplitude. What about the amplitude? Well, you know that when you multiply a trig function, you're going to scale it. So here I'm multiplying the trig function by 1/3. That means I'm going to scale the function by 1/3. Now, of course, the trig function is also moved around, so I have to be careful about that. That's what where the 0 point comes in. When I draw my 1/3, I'm going to center that 1/3 around the 0 point. All right. So far I've done this. I've identified the parent function, which is minus secant. I've identified the 0 point, which is minus 2 pi over 3, minus 3/5. The period is 4 pi. The amplitude is 1/3. So now I'm going to complete the sketch and put all this information. And I'm going to put the information in one by one according to this sequence. First of all, let me put in the 0 point. Okay, 0 point is minus 2 pi over 3 and minus 3/5. So that's this point here. Here's my 0 point right here. Okay. All right. Then I want the period. All right, the period. The period, I have to go up by 4 pi. So from here I go up to 4 pi minus 2 pi over 3. So that's the period. Okay. All right. Now, so let's see. Then what's the next thing? The next thing was I think the next thing was the amplitude, right? Next was the amplitude. Okay, identify the amplitude. The amplitude is 1/3. So that means I'm going to draw lines plus 1/3 minus 1/3. Okay. So this kind of gives me my x, orients my x and orients my y. My one period is from here, minus 2 pi over 3 to 4 pi, minus 2 pi over 3. And my y range is going to be from minus 3/5 plus 1/3 to minus 3/5 minus 1/3. So those are my two horizontal lines. Now, of course, secant does not lie between these two, but these two lines show me where the secant is. And now I follow the shape. In this case, when I have amplitude, my amplitude corresponds to the vertex point of the secant. Now, if you see here at the 0 point, I go down to minus 1. This is at the negative of the amplitude, right? The amplitude is 1, so I have this on the amplitude on the negative side. So that tells me this point here. That gives me this point here, which is the first point on my graph. Okay, so the first point that I can get on my graph is this point here, this orange point here. And I'm going to make red. This is the first point I can get on my graph. Okay, but now what can I do? Well, I know that it's periodic with period 2 pi, and they asked me to draw one period. So with it's period 4 pi. So my period is over here, so I go here. Here's my second point. I know these two have to be the same because the function is periodic. Okay. Now, from this, we can look at the shape of the parent function. Okay. If you look at the parent function, you can see this alternating cup shape. Down, up, down, up, down, up. Now it's pretty clear that the up cups are halfway between the down cups. Okay, so I have two down cups here. There's going to be a down cup here and a down cup here. I know it's going to go down. I don't quite know how wide it is yet, but I know halfway between there's going to be an up cup. So from here to here is 4 pi. Halfway between is going to be 2 pi. So if I go up 2 pi here, then I'm going to get this point also. That's going to be the vertex of the up cup. And then halfway between those, I have asymptotes. So now I'm really ready to draw everything. I have my asymptotes, I have my vertices, I can just draw it like this. Okay. Now you may develop your own sequence But this is one way to do it. Now, you wouldn't have to draw the period this way. You could have had a down cup and an up cup. That's also a period. So there's not a unique answer. There are many ways to do this. But this is one way, and I recommend you develop a systematic procedure for graphing trig functions. Okay, hope you enjoyed the video.